Hey everybody, Yumi here with PowerWeb Communications. We're here today with Peter Vaessen to talk about solutions to grid congestion with a focus on cables. Thank you, Peter, for being here and taking your time to speak with us. Can we start first with who you are? Can you please introduce yourself?
Yes, my name is Peter Vaessen and I'm head of the high voltage group of electrical sustainable energy of TU Delft. And I'm also responsible for technology and innovation of grid components at KEMA Laboratories.
So grid congestion has been a hot topic in Dutch news right now, and the government is looking for solutions. One of these solutions is to increase the load on high voltage cables. Could you please explain what this means exactly?
Yes, I have an example to show you. This is a high voltage cable. And if you look at such a cable, you see the central conductor here in the middle, and that's where the current flows. And when people talk about getting more load from a cable, they usually mean getting more current through this conductor. Of course, there are other solutions. You could increase the voltage, but you have to be very careful with that, because otherwise you can make a short circuit and there is a failure of the cable. So usually only increase current.
Increasing the current sounds a little scary to me. Is that a realistic solution?
Yes, it is realistic. If you look at the cable again, we talked about getting more current to the conductor, and there is a physical aspect related to this. If you push more current to the cable gets hotter, but it takes time to get hot. It will not happen immediately. So that means you have time. The moment you increase the current, you have time before it gets too hot, and that can take hours. So you can easily overload, what we call it, the cable, for several hours if you closely monitor the temperature and the current. So that's the physical aspect about that. But there is also a temporal aspect about that. During night, for example, there is no load on the cable. So you have actually a cable capacity lying there and it's not being used. And if it was possible to shift load from, for example, the day to the night, we would more evenly use the capacity of the cable. To give a very simple example, you at home, you can draw a peak current of 25 amps. And if you would draw that current your entire year, and if you would calculate how much power you could use, and that's roughly 10 or 20 times the average use. So most of the time you're only using a fraction of the capacity. But it is designed for the peak. The cable is designed for the peak, and that means that we have to take care that it's not too long overloaded.
I've heard TU Delft is doing research on increasing the electricity load on cables. Could you please tell us a little bit about that?
Yes, I can. So if we again look at such a cable, one of the directions is to get more current through the cable. And if you get more current through the cable, that means the cable gets hotter. But there is a time constant involved with that. It takes time before the cable heats up, and that means there is a time window, probably a few hours, that we can extra heat up the cable. So if we need temporary more current, we can do that. And that's a nice feature we can use if we have a temporary bottleneck to increase the load a little bit. The other direction is if we would say we have the cable, that's the capacity, compare it with a road which is there. And often we don't use the full capacity, especially not in the night, because people use electricity at a day, mostly during daytime. So it's actually how we behave determines how the cable is used. And you can imagine that if we are able to change the behavior of the people when they use electricity, then we could make better use of the cable. Although it has some problems, of course, people don't use electricity in the night. So what would be a solution? Charge a battery during the night and with the cable capacity that's available and extract the power from the battery during the peak that you need it on a daytime. So that's another direction we're doing research on it. And again, to monitor this all, we need sensors and a lot of artificial intelligence and data-driven models to check and predict. And a more fancy way to get more power out of the cable is get a different voltage on the cable. Nowadays most cables in the Netherlands are AC cables, alternating current. But you can imagine that if we put DC current, DC voltage on the cable, the same as we do with the chargers or the batteries, then we can get more power out of the cable. And the thing we have to investigate, of course, which cables are suited to do this. There are some cables lying in the ground which actually can accommodate different voltages, but some cables, like this plastic one, we have to be much more careful about, so we have to investigate what is possible. But there's definitely a way to get more power out of the cable.
Thank you so much, Peter. I learned a ton. Do you have any final words before we close out?
Yes, I think for the energy transition, the power grid is now seen as crucial, because this is seen as the bottleneck. You see all the efforts now going into reinforcing the grid, all the investments going on there. And I think that people thought, okay, if we just solve the generation issue, then everything will be fine. But electricity has to be transmitted and delivered from A to B, or even from your home to the home of your neighbor. So that goes through wires and cables, and that has been underestimated, and we saw it. And luckily, I think, people realize that, and we in Delft are really lucky that we have a lab like this, and we do now a lot of very relevant research for the energy transition, and in my opinion, we're going to make it, so I'm optimistic.
Well, thank you so much, Peter, for taking your time to interview with us today. And thank you everyone for watching the video. See you next time.